Hello, I am Noha M, researcher at Water Pollution Research Department, Environment and Climate Change Research Institute, National Research Center. Our talk today under title, Enhancing the Structural, Optoelectric, and Antibacterial Activity Properties of Carboxymethyl Cellulose Sodium filled with zinc oxide, graphene oxide and copper oxide, graphene oxide nanocomposites and their potential application in antimicrobial packaging. One of the biggest challenges in food packaging is the creation of sustainable and eco-friendly packaging materials to shield foods from ultraviolet photochemical damage and to preserve the distinctive physical, chemical, and biological characteristics of foods throughout the supply chain. Accordingly, this study focuses on enhancing the ultraviolet shielding properties and biological activity of carboxymethyl cellulose sodium, CMC, through modifications using zinc oxide, copper oxide, and graphene oxide using the solution casting technique. The hybrid nanocomposites were characterized by Fourier transform infrared spectrophotometer, ultraviolet visible spectrophotometer, scanning electron microscopy, energy dispersive X-ray spectroscopy, and X-ray diffraction. Significant interactions between CMC and the metal oxide, graphene oxide nanocomposites were revealed by Fourier transform infrared analysis, which reflects the formation of hydrogen bonding between CMC and the nanocomposites. Additionally, the CMC film showed a decrease in the optical bandgap from 5.53 electron volts to 3.43 electron volts with improved ultraviolet shielding capacity. Moreover, the composite films had excellent refractive index and optical conductivity values of 1.97 and 1.56 x 1010 ohm per centimeter, respectively. Scanning electron microscopy and energy dispersive X-ray spectroscopy analysis confirmed the dispersion of zinc oxide, graphene oxide and copper oxide, graphene oxide within the CMC matrix. Thus, indicates that the CMC nanocomposites have promising applications in packaging materials. These results were confirmed by the quantum mechanical calculations utilizing density functional theory. Total dipole moment, frontier molecular orbitals, chemical reactivity descriptors, and molecular electrostatic potential maps were all studied using the B3LYP, LANL 2DZ model. The total dipole moment and frontier molecular orbitals investigations revealed that the CMC, copper oxide, graphene oxide model has the highest total dipole moment and the smallest band gap energy. Moreover, CMC's reactivity increased after copper oxide, graphene oxide nanocomposites integration, as demonstrated by molecular electrostatic potential mapping. Finally, the antibacterial activity of pure CMC, CMC, zinc oxide, graphene oxide, and CMC, copper oxide, graphene oxide nanocomposite films was evaluated against Staphylococcus aureus and Escherichia coli. The zones of inhibition data showed that CMC, zinc oxide, graphene oxide and CMC, copper oxide, graphene oxide exhibited higher antibacterial activity than CMC alone, particularly against Staphylococcus aureus. The inhibition zones for CMC, zinc oxide, graphene oxide and CMC, copper oxide, graphene oxide against Staphylococcus aureus were 16 mm and 14 mm, respectively, suggesting enhanced susceptibility of Staphylococcus aureus compared to Escherichia coli. These results highlight the significant potential of zinc oxide and copper oxide nanoparticles in improving the antimicrobial efficacy of CMC nanocomposites. Thank you.